Hey guys, today we'll be using Unity's preview package, Project Tiny, to make Snake. Project Tiny is a new modular Unity runtime and editor mode designed to build games and experiences that can load instantly and without install. So basically it's a much faster experience. It can load things three to four times as many moving animated sprites while still maintaining 60 FPS. But one thing to note that right now, while it's in preview mode, we can only use this thing called TypeScript, which is like a temporary coding language that they added in until the preview mode is over, in which case they'll be adding C# later, making it even faster and more performant. But for now, we have to use TypeScript. But anyways, let's get started. I already have, or I guess I don't have anything opened yet. So let's make a new project. Okay, I'm going to call mine Tiny Snake. Go ahead and create your project. You need to have at least 2018.3 for this to work on your device. Alright, once Unity opens up, go ahead and go to your window in Package Manager. You're going to want to show preview packages, and then just search for Tiny, install Tiny mode. We'll wait for it to install. After the package is done installing, you'll have down here, or you'll have up here, you can go to Tiny mode, File, New Project. Then we'll name it. I'll name mine Snake. So now that we have Snake open, you can see which modules you're currently using. In Unity Tiny, you're able to strip certain things out of your project to make the build even smaller. We'll leave it how it is, and then we can play around with it later after the game's done. So the first thing we're going to want to do is go ahead and get the graphics that we'll need. We'll create a folder to put the graphics in. I have mine made already. Let me just go and drag them into the game. I'll leave a link below if anybody wants to download these. It's just a square and a ball that are both 64 by 64 pixels. You can go ahead and reduce the size of both of them to 64 to save on memory. Alright, now that we have our graphics in, we can go ahead and get started. The first thing we're going to do is make some components. We need I have a reference of the game open because I did do a few tests before to make sure I wasn't completely lost while making this video. Let's go ahead and actually rename our group to main group, which is when you create a new group, it gets put into your entities folder. Groups are, I would say they're like scenes, but Unity Tiny doesn't actually use scenes, it uses groups. So let's rename this to main group. But they are pretty much like Unity Tiny's scenes, although they aren't really scenes. In our group, we'll create a new sprite. We'll call this player. You can see it already has a white square. I guess you could use that if you wanted to, but we'll go ahead and drag our element in so it's the correct size. We know it's 64 by 64. Alright, now we need something to so basically how the entities work in Unity Tiny is you make components and add it to it, and then in the script you're able to reference certain entities that are within the scene and see if they have the right components on it, and then you're able to access them and do things to them. So let's create a component for our player. The first thing we'll create is a boundaries to let it know where it needs to go inside the screen. Before that, let's actually set up what our Project Tiny screen should be. So if you go to, let's see, actually I'm not sure if I remember. Oh yeah, go to Project Settings, and then if you go to something, one of these, I know it's on here, somewhere. To auto resize canvas, I'll use 1024 by 512. Of course, you can use whatever ratios you want, but this is what I'll be using for mine. And now we'll go back to making the component for our player. We'll make a boundaries component to let it know where the edges of our screens are. All of your tiny stuff is within this tiny area, and we'll create a new component. We'll call it boundaries. I feel like that's misspelled. I don't know why. It looks weird to me. Yeah, there's an extra I. Ha! I'm a genius. Anyways, moving on. We'll add this component to our player. And we need to add new floats. We need 4 floats on our boundary. We need a minimum X, a maximum X, a minimum Y, and a maximum Y. So we'll go to add new field, built in, float 32, min X. I don't know why I keep thinking it's right there. Built in, float 32, min Y, or my bad, max X. Built in, float 32, min Y, built in, float 32, max Y. Now on our player, we can set our boundaries. And so to figure out the boundaries, you can go to your camera and you can see that the max size is 5. And then if you look at our project settings, you can see that our ratio is 2:1. So I believe if we use on our Y negative 4.5 and 4.5, and then negative 9.5 and 9.5, that should give us an area that's pretty close to the edges of the screen. I could be wrong. We'll test that once we get the movement in. Alright, speaking of movement, let's add a component for controlling the move speed. We'll call it move speed. It needs a float 32. We'll call it speed. I'm going to go ahead and set it, or well, not there. We'll add it to our player. And I'm going to set it to 0.64 because that's the size of our object and we want to move one object over every movement. So 0.64 should move it over the amount that I want. We'll also test that when the movement gets added in. So we need another component to let the script know which object we want to move with our input. So we'll just have a tag called move with input. And anything we tag with move with input in our input script will move with the input. It doesn't need any values because we're just using this as a tag. We'll also go ahead and create, well, no, that should be all we need to get the movement working. So we'll go to our scripts. We'll create a input movement system script. And you can't just use the C# like I said earlier, you have to use their new TYPESCRIPT system. There's also a behavior. I don't think we'll need those in this video, so I won't be talking about them, but there are excellent sources where you can go and read about them. I'll try to leave links in the description below. So I'll name it Input Movement System. And we'll go ahead and open that up in Visual Studios. Alright, so this is what TinyScript looks like. It gives us a namespace, and then we have our export class input movement system, and it extends the UT component system. And here, so it gives us an auto-generated on update. So let's go ahead and start doing some things. We'll put a static direction, and it's going to be a vector 3. and we'll go ahead and set it to a value of 0. We don't need to play with Z. I could probably just use a vector 2, but when accessing the position, it sees it as a vector 3, so it's just easier to use a vector 3 and not use the Z of it. Okay, so in our onUpdate, we need a reference to the delta time, same as within normal Unity. You use the delta time to keep the speed consistent across multiple frame rates. So we'll make a variable called dt and set it to the delta time, which is within this.scheduler.deltaTime. And now we need to find the component that we want to move with input. So to do that, within TypeScript, we'll use this.world.forEach, and then for each, I'm trying to think which components we're going to need access to later, because within the for each, you also put your references to the variables that you're going to be using. So I believe, well, I'll just add them, and if we don't need them, we'll remove them later. We'll use ut.entity. We'll look for a game.moveSpeed. We'll look for a game.moveWithInput, a game.boundaries. These are all the components that we made earlier, and this is a built-in Tiny Unity Tiny component, which is the entity, which is these right here. These are the entities within a group. Okay, so moving on. We'll also look for, it needs something to move it with because we're moving, and the thing that moves it in or in Unity Tiny is accessed through ut.core2d.transformLocalPosition, and then we'll close this bracket off. And now we need to place these accessed components into variables so that we can do things with them. And to do that, we'll just open a parentheses and start naming the variables. For ut.entity, we'll use entity. For moveSpeed, we'll use speed. And then tag, bounds, and position. Then we'll do this fancy thing. Open a bracket up. Close a bracket. We'll close the parenthesis that we opened at the beginning, which is right here. And then we'll semicolon it. Now let's do things within it. So we are going to access input, and to do that inside of TypeScript, we'll use ut.runtime.input, and then we'll get a key. The key we want to get is in ut.core2d.keycode, and then the key will be W. We'll go ahead and copy this and place all of the buttons that we need. Oh, fancy. A, S, and D. I'm going to use S and A, actually. Alright, so under the first one, we're going to set our direction to the direction that W would be. So to do that, we need to access this direction, which is static. And you would think that you could just do direction dot, but as you can see, it's not showing up here. If you have something set as static, it's on this system. So you need to access the system to get the variable. And to do that, we'll just do game dot input movement system direction, and then we'll set it to the direction we wish it to move, which would be a new vector 3, 0, and then the amount of y that we want to move is the speed that we set up within the game.moveSpeed. So we'll access it with the variable that we set up here, which is speed.speed. And that'll move us 0.64 upwards every on update when we push W. We're not using, or I guess we can go ahead and put DT here. We'll be changing the movement up in a little bit, but we'll just see how this works for now. It's not exactly going to move us 0.64 right now. So for S, it's just a negative speed, and then for these, we'll move this to the X position, make the A a negative, and then add our Y back on. So we have our input set up. We can access our input. We know which direction we want to move. So now we need to actually move the entity. And to do that, it's also pretty simple. Okay, yeah, of course, our position's right here. So we just need to access that and then put it where we want it to be. So we'll do position.position equals, and what we need it to equal is our current position plus our direction, which would just be, we'll set up a variable to store it actually, and then we'll set it, which would be let new position equal position dot position dot add, and then we'll use game dot input movement system direction, and then we'll set our position to new position. This should work. I could have done something wrong. We're about to find out. So when you run a build in Unity Tiny or within the editor, it opens it up within your browser and not in the editor because it's actually an HTML5 file. And you also get this nifty QR code. And if you use your phone and use the scan QR code feature, it'll actually go ahead and load the same build that you're running in the editor on your phone. But let's see if this worked. Look, we have movement. Excellent. Now we just need to make it move 0.64 every frame, or at the speed that we want to move at, and not every frame. To do that is pretty simple. We'll go back to our Unity. Go into Tiny Snake. And let's set up some counters. Alright, so in the update, we're going to use game. Every frame will increase the input, or the counter, my bad. And how much we want to increase it is going to be plus or equal to dt. Simple as that. And then we'll take the dt off of here. We're going to redo this also. Actually, one thing we also want to do, if we put the counter around our input, we'd only be able to do the input every frame that we move, but we'd want to do our input every time we touch the keyboard. We don't want to be able to only do it during the frame that we're moving. So we're going to set up a new this world for each for the movement itself instead of the input. We'll separate these two. We could probably make another file to do the movement instead, but we'll just do it in here for simplicity's sake. I knew something was confusing me. Something just wasn't looking right. So we'll make a if game.inputMovementSystem.counter is greater than game.inputMovementSystem.cooldown. Then we'll allow the movement that we're going to be adding in here. And then once it ticks, we will reset our cooldown back to 0. To do that, we'll do game.inputMovementSystem.counter. Oh, I'm just great at typing, aren't I? And then we'll make a... We'll actually do this outside of the for each loop. And then we'll get our current position, so our local position. Which is we accessed from this. So a local position is position.position. And then our last position is a... Why we need last position, we'll be using this for the tail piece to move it, so we'll go ahead and set it up now. Is a new vector 3, which is our local position dot x, local position dot y, and local position dot z. I found out if you just say last position equals local position, it just makes it a reference to local position, and last position will update with local position when you try to access it later, which messes with the way I'm setting the code up, so we'll have to actually create a new vector and copy the values over this way. So every time we move, we just want to move our local position in the direction of our direction, which is accessed through game.inputMovementSystem.direction. We can also clamp our boundaries right here to keep our snake on the screen while we're moving. To do that, we'll use local position.x equals math.max. Then we'll use our bounds that we got a reference to earlier. Our min-x, and then our math.min, bounds.maxx, and local position.x. We'll do the same thing for our y. And this will keep our snake on the screen using this math.max and math.min. It'll make sure to return a value that's always within the values that we set up within bounds. Now we want to see if we did move this tick, because if we didn't move, we don't want to update our last position. So if local position dot equals, or does not equal, since we added the exclamation mark at the beginning here, that makes it the opposite of equals, or the opposite of whatever our value returns. So even if it returned, I'm not sure actually. Anyways, I just know that it's going to return false. What I was going to say is, if this was returning a false and you added this, it should make this if it's true, but I'm not 100%. I've never done that, but I do know if you have a bool, say this bool, or let some bool equals some bool, it'll just flip some bool every time this calls. So I'm assuming it would be the same here. If this was false, this would make it a positive. But anyways, moving on. That's completely irrelevant, so... Why is it not letting me access this? Did I not? Oh, haha, I haven't set up the static variable for it yet. Static last position. It's also a vector 3. So now... my bad. So last position will be set to the last position that we have accessed here, and then we need to actually move our person. or snake, which will be local position because that's the value that we edited earlier. And now let's see if it moves every 1 tick and see how long 1 tick is while we're at it. There we go, and it looks like it's moving 1 object over pretty perfectly. Does it move up? It moves up, backwards, and down. Alright, we have movement. We have movement! So the next thing we're going to want to do is make a tail system. We would need a tail to follow our object, and I guess we'll make the food spawning system first, so we have something that makes our tails move. That makes more sense, right? So let's make a food spawning system. Go to Create, Tiny, TypeScript System. We'll call it Food Spawner System. Go ahead and open that up in Visual Studios. This is going to be a pretty short class. This is actually our hardest class to write. The rest of them are pretty easy. And all this is a simple left, right, up, and down movement. So that says how easy Snake should be to write, right? So let's make a static reference to the food that's on the screen, because we only want to spawn a food when there isn't a food. And if there is a food, we don't want to spawn another food. So the easiest way to do that is just to keep a reference to food, and if it doesn't exist, spawn some food. So it's a ut.entity. I believe we talked about that earlier. A ut.entity is the entity that spawns within the groups in the scene, or the group, not the scene, because the scenes don't exist in Unity Tiny. Alright, in our update, it's going to be a pretty small amount of code, just game.foodsystem.food. I think we can actually use this.world.exist game.foodspawnersystem.food. So if that entity exists, but we want it if it doesn't exist, then we'll do game.foodspawnersystem.spawn, which is a thing we haven't made yet, but we'll make it in a minute. And we're going to push the world through it, and we're going to push game.foodsystem.food object, which we also haven't created. And what food object is going to be the name of the group that we're going to be instantiating. In Unity Tiny, you can't instantiate just these entities. You have to instantiate an entire group. So we're going to have to create a new group, entity group, and we'll call it food group. And then in our food group, we'll create a 2D object sprite. We'll call it food. And we need to put our graphics onto this sprite, which is our ball that we brought in earlier. You can't see it because it's under the square, but if you just move it over, it's there. Save your food group. We'll add our tags to it in a minute. Let's finish writing our code first. So now that we have the name of our food object, let's create the food object within our food group or food system. Oh, maybe put it in the right spot. That usually helps the code run better. A little less buggy when you do that. So it's going to be a string is how you access it, and the string is game.foodGroup. And now we need to create our spawning void. To do that, we'll just do a static spawn. And we need a world reference, which is a ut.world. We need an entity group reference, entity group, which is a string. Open her up, and then within this we're going to spawn it, And we're going to actually be creating a Utils class for our spawning, because spawning is strange and it's simpler with a util class. So go to create tiny TypeScript system. We'll call it Utils. And within Utils, we're going to make this module. Rename this to Utils. And then erase this stuff. I guess we could have just erased everything and started over, huh? So we need a function to be accessed from Utils. We'll call it spawn. It also needs a reference to the world, ut.world. An entity group, Spelling seems easier when you're not saying it while you're typing it. Now we need a position, but maybe we don't want to put a position, so we'll set it default to null. And then we need an entity index, because you are actually spawning the entity. I know I said earlier you're not spawning entities, but actually you are spawning entities. But you have to spawn the group and then access an entity within the group. Like if I spawned 0 from main group, it would spawn a camera. If I spawned 1 from main group, it would spawn the player. But we want to spawn 0 from food group because 0 is our food in the food group. So go back into here. We'll create an index for that. Entity index, which is a number, equals 0. Capitalize your vector3 to make that actually work. And now in our spawner system, we're going to have let entity, we'll call it entity. We didn't use that, right? World, entity group, position, entity index. All right, we can use entity equals ut.entity group dot instantiate. We'll instantiate it into the world that we passed. We want to spawn the entity group, and we want to spawn the index that we passed. Now, if we have a position that we pass, we want to also move its position. So if position is not equal to null, we'll use the component of the entity within the world, which we'll do by going world.using component data of the entity that we just spawned. The component that we want to use is the ut.core2d.transform local position. And then the variable that we'll name that as is transform local position. Open it up. And then in here, all we have to do is set the position to the position that we want to move it or spawn it at. And then we're also going to return the spawned object in case we want to do anything with it. So all we have to do is return entity. And now this will return this, even though we don't have it set up as what type to return. It just knows. We'll also go ahead and set up a getRandom function while we're in here, just to make our lives a little easier. We'll be using this to spawn the food on the screen anyways. We're literally going to be using it right now, so I guess this is actually the time we need to add it. So math.random and Unity Tiny gives you a number between 0 and 1. So we'll just multiply that by our max minus our min plus 1, and then close that, and then add our min to it, and that'll give us a random number that we need. Alright, back into our food spawner system. Into our spawn, we'll have game.foodSpawnerSystem .food equals utils .spawn world entity group, new vector 3, utils dot get random -8 8. We could use variables to store this or something else. There's various ways we could do this, but I'm just going to put them in. Utils dot get random -4 and 4, and that should be all we need to spawn our food in. It should be, if the food doesn't exist on an update frame, spawn in a new food. So every time it gets deleted, it should auto spawn itself back in. Let's see if this spawns a food into the world. There's our food. Now the next thing we're going to do is create the eating system for when you eat a piece of food. To do that, we'll just go to our scripts, create new tiny TYPESCRIPT system. We'll call it eating system with 1 E, not 2 E's. I guess if you want 2 E's, put it, but I'll use 1. Within the eating system, we need to use a variable or a boolean, which is a variable, to let it know if it did hit, because you can't actually do things within the for each loop that we're using, because the entity is like being set up within the for each loop, and it's not created and accessible until the for each loop is done. I'm not sure if this is true for destroying the entity, but I'm going to assume it is and do it just to be safe. But when you are instantiating an enemy and then you want to make a reference to it, and you have your for each like right here, we have this spawn. We're going to be spawning it. If this had a for each loop in it and we spawned it, and then we made a reference to the food from within the for each loop, when we tried to access that reference, it would return a -1 or non-existence, and pretty much it just wouldn't work. So you have to make references to the spawned object after the for each loop is closed. It's very important. I spent a few hours figuring that out myself. Very important. So let did hit equals false. This dot world dot for each ut dot entity is what we are looking for. It needs an entity. It needs a core 2D dot transform local position ut dot hitbox. We haven't talked about that yet. We'll talk about it in a minute. Hitbox overlaps results. And then a game.food tag. What'd I do wrong? Oh, we haven't created the food tag yet. Of course. Go back into here, go to your components. We need a food tag to put on the food. Go to tiny, component, food tag. We'll also go ahead and create our player tag. And let me think about what other tags we may need. I'll go into my reference project and just take a peek. We have our boundaries, our food tag, our move speed, our move with the input, our player tag. Oh, we need one for our tail. Tail tag. Alright, so let's add the player tag to our player. And now we need so we don't need actual physics in this system, we just need a hitbox 2D. So we need to go and turn that on within the modules of our game. We won't need HTML. I don't think we need this. I don't think we need this. We need this. We'll turn our hitbox 2D on, go back to our player, add the hitbox 2D component, rect hitbox 2D. Now we need to position it our size is 0.64 by 0.64. Then we need to put it at negative 0.32, negative 0.32. And now, if you notice, the component that I added is a rect hitbox 2D, and in our code, we are looking for a hitbox overlaps results. How this works is when two objects collide within Unity Tiny, it adds a temporary component named hitbox overlaps result. So on the frame that's added, it is found within the for each loop saying, hey, this object with these tags that you specified now has an overlaps result. What do you want to do with that? So what do we want to do with that? We'll do our foo tag now that we added it. We'll references as entity, position, contacts, and tag. Now within our for each loop, all we're going to do is did hit equals true. Actually, we will be destroying it within the for each loop, so maybe that does work, but we won't be spawning our tail within the for each loop. Now, after you destroy your entity, you also want to set your food to null, because I noticed that, or well, it should work. In my previous project, I was checking for it to be null, but in this one, I'm checking for it to exist. So we're not going to add in the null just to see if that works. If it doesn't, we'll add in a null. So after the for each loop is done, we're going to do did it hit? If it did hit, we're going to do game.tail system, which we haven't added yet. We'll be adding that now. Spawn tail. We'll go ahead and pass our references. We know what we're going to be doing, so why not type it now, and it'll fix itself once we add the rest, right? Right. Maybe not. We'll see if this was a mistake or not. So we're going to be passing our world and our tail object, which is going to also be within our tail system. Tail system, spawn tail, tail system, tail object. All right, let's go create our tail system. Within our tail system, we'll create those objects that we were just referencing, which is our tail object, which is going to be the entity group name for the tail that we'll be spawning on. Game.tailGroup. And now we need an array of our tails, so that in Snake, we need our tail to follow our object, right? So if I go into Paint and just try to draw like a little thing of this, in Snake, our object will be always moving in the direction of our head, right? But we don't want to access each piece of our tail and be like, hey, you move to here, and then you move to here, then you move to here. In reality, all we have to do is move our head here, move this tail here, move our head here, move this tail here, and so on, without, hopefully our code doesn't cut our tail in half. But yeah, you get the point. It makes smooth movement with less code. So we'll make an array of tails. Even if you weren't doing it this way, I'm pretty sure you would still need an array. Our array is an array of entities. We'll make it a new array. We need to go ahead and create the array, or else it would say our array has not been instantiated, created, something. Hasn't been something. It wouldn't work. That's the thing. and we want it to work. We don't want it to not work. That's why we're here, right? To make things work. We're not going to be using onUpdate, but if you take onUpdate out, then the thing that it's extending, it no longer works. You have to have onUpdate in. So static onMove will pass in a world into onMove. And that's all we need to pass in. It's a void. Now within here, we're going to be saying, does our tail have a tail piece? Game.tailSystem.tailArray is the length greater than 0. If it is equal to 0, not greater than 0, return, because it doesn't have a tail, so we don't want to move our tail because then we'd get an error. And we're trying to avoid errors. So we'll make a reference to our last tail equals game. Now the one thing about the TypeScript, it's more like JavaScript, so it actually makes making the snake game a lot easier. We can use pop and unshift to simply do this. What pop does, if you read, it removes the last element from an array and returns it, which is exactly what we want. Now after we return said last tail, we'll use world.usingComponentData of last tail that we just popped. We've done this 5 times. I don't think I have to tell you again what I'm doing. So using the component data that is now stored in transform local position, is that the error that I got? Okay. That is now stored in transform local position, we'll do transform local position dot position equals game dot input movement system dot last position, because that's doing what we just explained earlier. We popped it the last tail off, we put it in last position, which is the position the head was in the last frame before it moved, so the position that our last tail needs to move to. Now after we moved our tail, we just want to re-add our tail to the beginning of the array, which we can do with unshift. And as you can see, inserts a new element at the start of an array, which is perfect, right? Now we need to make our spawn tail. This should actually probably be a capital S. That makes more sense. Get a reference to our world, a reference to our entity group, then we'll make a reference to the tail equals that will be instantiating using our Utils class that we created. Then we'll be pushing a tail into the tail array because we spawned a tail and it needs to be added to the array, which is as simple as tailArray.push. And we aren't just going to push tail. That might work, but after reading a few things on the forums, I think it's safer to do it this way. Alright, I think that's everything. All we need to do now is actually create our tail group inside of Unity. But let's walk through our code. We have our movement. So we have our movement outside of our counter. we have the movement of our head. We have a food spawning system. We have an eating system. We have our tail system with on move and spawn tail. So when you eat something, it'll destroy the food, spawn a tail, a new food, a spawn, a tail will spawn, and then the tail system movement will, I knew that's what we're missing. Haha, I knew we were missing something. Good thing we walked through the code. And here we need a variable called moved to tell whether or not our object actually moved, and then tell the tail to also move. So we'll have a let moved equal false. Then down in here we'll do moved equals true, and outside of our for each loop we'll do if moved. Not 100% sure if this has to be outside the for each loop, but we're putting it outside the for each loop. Alright, let's see if the game runs. Oh, after we create our new group. Our tail group. Create entity group. Tail group. And our tail group needs a 2D object, a sprite. The sprite is the snake, the same exact graphic. Save our tail group, save our food group, unload both of these, click play and see what happens. Let's open up our console so we can watch for bugs. She's moving a bit slow. We'll speed that up in a minute. Alright, we obviously forgot to do something. Let's go back into Unity. I'm sure somebody watching this knows exactly what I forgot to do. We should probably add the components that we need to our tail and our food. So let me just check my reference to make sure I don't mess anything up, just to make this faster. Oh yeah, a thing to teach y'all real quick. See this little button right here? This is a family of your component. In Unity, this is what your components would more look like, but if you were to... In the video I was watching, there's a way to undo the familying, but maybe they didn't. Maybe they took that out. But anyways, you can actually turn off the things that you're not using. So we aren't using the local rotation or the local scale, so turn that off. We can go into our player, do the same thing. Open up our food group. We'll do the same thing for our food group. So we need to add our tags. We need our tail tag. We need our food tag. Believe that is everything. Our food needs a rect hitbox 2D also, because we're actually accessing it on the food, not on the player. The one that we added to the player is going to be for the interaction with the tail. So add tiny component, add a hitbox 2D, rect hitbox 2D, the same values that we put in before. So we have our food tag, our hitbox, our tail tag. And it seems like it's working. Let's open our console, make sure we don't have any errors. Let's actually speed it up real quick. That is killing me how slow it's going. If you guys remember, we set up a variable in our movement system that controls the movement speed. it's actually this that controls speed. Speed is actually controlling the distance that we're moving. So that's a little convoluted, right? But that's okay. So speed is the distance that we move per movement, and the speed of the per movement is cooldown. So right now we're at 0.1. That's pretty freaking slow. Let's try 0.1. Much faster. Alright, let's make sure it actually works. Open our console up just to be sure. This seems like this is a snake game. We haven't checked our boundaries yet. Let's see if the boundaries work. That worked. That worked. That worked. It looks like it might be eating a tail, or maybe it just seems like that. Like one tail is disappearing when you slam against the wall. I can't exactly tell. Tail. Alright, this is how you make snake in Unity Tiny. In the next video, we'll be adding in the UI and the tail interaction, because right now you can go through your tail. But if you guys want, you can go ahead and add that in yourself, or wait until the next video. Until then, have a great day. Don't forget to like and subscribe if you enjoyed the video, if you learned anything. See you later.